Hello, Maurieo! How to convert from polar to rectangular with the CASIO FX82 ES. Hello! In this video, I'm going to do some polar to rectangular coordinates and vice versa, and rectangular to polar with the CASIO FX82. Previously I've done this with other calculators, so I'm going to use the same information, the same data, and so you can see how we could get similar answers from that. So there are my previous videos in my collection which will do this with an HP calculator previously, and I'm now going to do it with the FX82, which seems to be the most common calculator that I encounter with my surveying students. It's probably the most cost-effective calculator that's available from the larger suppliers. So let's go to the large screen and let's look at the first slide, and let's bring up the FX82 ES. Here it is here, sitting out there like that. So this is a fairly familiar traverse that I have done, and obviously the process is that you would put in the bearings and distances around the traverse and take out the northings and eastings. Typically, the way that I've shown people to do it on the FX82 to date is to take the cosine of the bearing and multiply it by the distance to give the 132.44, and then take the sine of the bearing times the distance, and that'll give us the 62.55 for the easting, and then that carries on through to the coordinates. So we'll have a look at how you might go about doing this. So first of all, these are polar coordinates here, the degrees, minutes and seconds. That's a polar coordinate, okay, and these are rectangular coordinates here, so going from polar to rectangular. Alright, so to do this on the calculator, first you need to just set up your calculator. So we'll just first of all mode, and we'll just go with 1, this thing, and then shift mode, and we want to be in degrees, so that's 3. These should come up along here, but doesn't seem to, that part of this emulation doesn't really work, but that should be like so. And I'll just notice here that we're working to 2 decimal places, so I'll set shift mode 6, and I'll just set it to 2 decimal places. Okay, so let's just check that. 23 times 0.563 equals, and it comes to 2 decimal places, so that's all good. Alright, so for the first one, we just go shift, and you'll see here polar and rectangular on the, just in here, so polar, okay, and it puts a bracket down. Now it likes the distance first, so 146.47, and then you need to go shift, and we're going for that comma there, put the comma in, 146.47, and now we put the degrees, minutes and seconds in, 25 degrees, 16 minutes, and 50 seconds. Okay, and then close the bracket, and we go equals, and there it will give you the 146 0.47, 25, oops, let's center. No, I must have perhaps not gotten something quite right. It's very, I can't work out how to get up into that upper level there. So that hasn't worked out quite so well. Oh, that's because I've gone with polar and I wanted to go to rectangular. So that's a bit of a rookie mistake there. But, you know, that's one that we mean. So make sure, so we're going from polar to rectangular. So I should have pushed rec rather than pole. Okay, so yeah, it does pay to do some of these beforehand. I have done a few, but just made a real rookie mistake there. So let's just go shift, and it should be rec that I'm after because I want rectangular coordinates. And then I put in 146.4.47. So check this very carefully because it's not possible to adjust or change it. Shift, comma, and then 25 degrees, 16 minutes, and 50 seconds. Now, yeah, that is important that you do that, because even though I put in all those wrong, put in the wrong values, I still get an answer out which could or could not be right. So it's very important that you maybe just check the first one you do, just by taking the cosine of the bearing and multiplying it by the distance, just as a check. And now we push equals, and you'll notice here that it's got 132.44 and it's not showing it to 2 decimal places. And if you push the little thing here, that'll show you the y value, 62.5501. You'll see they're both positive, which is what they should be. Now, if you want to get it to 2 decimal places, what you do is it actually stores these in these X and Y memories here. So you just go recall X, and there's your 132.44. Okay, and then you go recall Y, and there's your 62.55. So that's them rounded to 2 decimal places. Let's try another one. Okay, so it's shift rectangular, REC, shift rectangular, and then the distance first, 174.37, comma, and now the bearing, 103 degrees, 27 minutes, 40 seconds, close the brackets, equals, and then just go, I would suggest just go recall X minus 40.59, and that does all the rounding and everything for you, and then recall Y 169.58, so it gives you the negative sign and everything and what have you. Possibly if you get to know your calculator a bit better, you can work out ways of accumulating and adding these as you go into the various into other memories and things like that. And if you have the programmable calculators, you can probably write little programs to do this if you're up to that. So let's just do one more of these, perhaps this one here where they're both negative. So again, it's just shift rectangular, rec, REC, and then 225.48, shift, comma, and 236 degrees, 11 minutes, and 00 seconds, close the brackets, equals, and then recall X minus 125.49 or negative 125.49, and recall Y minus 187.33. So yeah, that's the rectangular to polar, and as you can see, very important that you get that right, as you saw there right at the beginning, where I put the polar coordinates into the polar function there. Still got an answer, which I could have written down, but it would be totally incorrect. So important that you either know how to do this, or if you're going into an exam situation, or you just do the check. So 25 all clear. Yeah, just cosine 25 degrees 16 minutes 50 seconds, close the bracket, times 146.47 equals 132.44. So I have shown you how to do it using the cosine and sine. Cosine for the north, sine. So it might pay, and if you're a little unsure just in an exam which ones you want, which function you're going to need, that this is the one that you put in polar and push that to get rectangular. This one here you put in rectangular to get polar, and we're going to have a look at that next. So you need to be very careful with this, because it's easy to make a mistake, and big time. That's going to take up a lot of time trying to sort out. So let's move on to the next slide, and this is from another one of my videos, and this is where we're doing joins. So we're going into the reverse. So what I've done is shown you how to do it here, just using the basic functions of sine and cosine. But essentially what happens is you've got these two coordinates here, and they've been written down here. It always pays to draw a diagram so that you can just approximately see how things are. Okay, so what we've done is we've subtracted the this northing here from this one here, and that's given us the distance there, minus 738.054. And then we've calculated this easting from this easting, and that's given us the distance 561.874 in here. And so we want to work out the bearing and distance from A to B, from A to B. So let's just check. To get from A, we have to go minus 738.054, and then obviously minus 561.874. So in this instance, we put them in with their signs. Now, previously, to calculate the distance, we just used Pythagoras, squared both of them, and then took the square root, which gave us the distance. And then to work out the bearing, we calculated this angle here, which was tan to the negative 1 of this over this, 561.874 over 738.054, which gave us the angle there, 3716.54. But we know that our bearings go clockwise from north, so we had to add 180 to that to give us 217.16.54. So what I'm hoping, or what I'm planning to do now, is that we'll put these values in. This is the north and this is the east. We'll put those values in, and we should get these same answers here, there, actually to 3 decimal places. So let's work to 3 decimal places. Shift, set up, 6, 3. Okay, so let's put it in 3 decimal places mode now. All right, so obviously these calculations will be done, so we'll use them. All clear, and we just go shift, and this time we use the polar. So we're going to polar from rectangular. So we go negative 738.054. So that's the north one goes first, shift, comma, and then we go 561.874 like that, and then we push equals, and that's our distance there, 927.592. Okay, and if we flick along here, we'll see we get our bearing, but our bearing is in decimal degrees, so we need to convert it, and we can't convert it there. So once again, of course, we recall x, and there's our distance, and rounded appropriately, 927.592. Whoopee, got that one right. And then we recall y, and that'll be in decimal degrees, and this might cause a little bit of a problem. Oh yes, and there we can just flick on that button there, and we get, whoops, 142.43. That's not quite right, is it? 142.43.05. Okay, so the angle that we've got there is, all right, we've got the smaller angle there, 142. Now that's not the correct angle. I'm pretty sure. 37. That's 180 minus the 37, which is the incorrect angle. So we need to subtract that from 360. So if we go minus 360 equals, and we get 217.1654. Okay, so yes, 217.1654. So we just have to be a bit careful there as to what angle we get, as this, I think this possibly only gives the angles between 0 and 180. So we have to be, that's why we need to draw a diagram, just to be very careful as to what the angle is, the angle that we're getting. So in fact, we've calculated this angle here. Okay, I'll just I think I know what I've done wrong there. I'll just check all clear. I think I forgot to put the negative in for there. So let's just go shift polar. So that's shift polar, yes, negative, I think I might have done that, 738.054, shift comma, and negative, yes, I think that's what I did, 561.874, like so, and push the equals, and yes, we get the correct distance there. And let's just have a bit of a look along here. What do we got there? And we got minus 142. Yes, minus 142 is the angle. Now minus 142, you just add 360 to it and that'll give it to you there. So it's only, yes. All right, so if it's negative, add 360. So we'll go recall y, recall x here. There's our distance, and then recall y, and then we'll go plus 360 because it's a negative angle. So you just add 360, and then we'll push that, and that'll give us 217.1654. Okay, so yes, it's very important that you put them in with the correct sign. As you'll see there, I was actually putting it positive out here. So I got the correct distance, but my my bearing was incorrect. But I could tell from my diagram, because I'd drawn a diagram, I could tell that that bearing was incorrect, and so that, yeah, I was able to go back and get it correctly, and then my answer came out as negative. So negative angles are ones like clockwise is positive, so negative is anti-clockwise. So you just add 360 to give you that there. So, but let's do one final check on that, and that is to go back the other way and go from the polar to the rectangular, which is shift rectangular, shift rec. Where's the rec? Oh, I've lost them all. Yes, and then we could just go in there. We could go recall X. Oh no, it's not gonna. Probably not going to do it, but I'll type it in. So that's 927. Oops, I'm doing it on the keyboard. 0.592, comma, shift, comma, and then 217. So you can always check by going back the other way, obviously, because one undoes the other. 1654 bracket, and make sure we get the answers. So minus 738.055, so a little bit of rounding error there possibly, and minus 561.874. let's just get them all rounded. Recall X minus 738.055, so a bit of a mill out there, which you get with this sort of thing, and recall Y minus 561.874. Okay, alrighty, so that's the polar to rectangular with both of those there, and it's given you some examples here to work with on the calculator. Now, some of your other calculators will be slightly different, so you need to look for the polar to rectangular button. Some of the earlier calculators don't have the X and Y, and they have an F. You have to use the F button up there for the Y values. There's a button up there, the F, A, B, C, D, and they use the E, then F button, and not the X and Y. So you need to work out the particular peculiarities of the calculator that you have. Those of you that have the calculator, the programmable calculators, again, it can be a bit of a mission. I'd have to have a look at it and see just how that's going to go, how that's going to rock, but it can be done on all of these. Now, like I said, this way here, it is possible, to do it using these things here, but you have to be very careful with them as to what you use and how you use them, and to make sure that you are doing the right thing and that you're experienced with it. But if all else fails, you can of course go back to the basic principles which I've shown you. Firstly, here using the Pythagoras and tan to the -1, always draw a diagram, always helpful. And then also I think, we can get this to go here. We can always go with the cosine of the bearing times the distance will give us the north, and the sine of the bearing times the distance will give us the east. So we've got these fallback options, and you've all been doing them those ways up to now, and so you've got the basics there. You can always go back to basics, but if you want to save a little bit of time and get some practice in, you can get very proficient with the polar and rectangular keys. So there you go. There's a lot to think about there, and yeah, cheers. See you.